This is Chapter 8, Lesson 1, and we're talking about factors and multiples, which are kind of opposite sides of the same coin, and I'll explain that. Our essential question is, how can different fractions name the same amount? And we'll get into that in more detail later on. For now, we're just talking about the factors and the multiples. And let me explain. Factors are numbers that are multiplied together to form a product. The two factors that are multiplied together are the factor pairs of the product. So just as an example, to clarify the difference between a factor and a multiple, let's take a basic problem. 2 times 5. 2 times 5 equals 10. Now, one part of this problem is a factor, and one part of the problem is the multiple. In fact, all multiplication equations have two factors. Both the 2 and the 5 are the factors, and the 10 is the multiple. So anytime you're doing a multiplication equation, the two numbers that you're multiplying are called the factors, and the product is the multiple. So that's why when we're counting by 5, I say 5, 10, 15, 20 are the multiples, because those are the products of those first 4 operations, 1 times 5, 2 times 5, and those 1 times 5, 2 times 5, 3 times 5, 4 times 5 would all be the factors. So the numbers that we're multiplying are the factors, the number that we get is the multiple. That's how they're sort of opposite sides of the same coin, because they involve multiplication, and one part is the problem and one part is the answer. So as we're looking at these problems that they've given us here, everything in this box will be which? This will be all factors. And in this case, the multiple is all the same, because the multiple each time is 48. And we're trying to see, according to the question that's being asked here, what are all the possible factors of 48? Okay, so we're arranging 48 strawberries in an array on a tray. Find all the factor pairs of 48 to see what kind of arrays can be made. Draw and label one of the arrays. Okay, so we've got 1 times 48 equals 48. 2 times 24 equals 48. And 3 times something gives us 48. If we count by threes, or we divide 48 divided by 3, either one, we'll get 16. 3 times 16 is 48, so this is another factor pair, and 3 is a factor, and 16 is a factor. If you get a remainder when you're dividing, or if you don't say 48 when you're counting by threes, then 3 would not be a factor of 48. Now 4 times something will get me 48. 4 times 12. And 6 times 8 is 48. So these are all the factors. Now we went 1, 2, 3, 4, 6. Why didn't we say 5? Well, because if we do our counting by fives, we're not going to say 48. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. We're going to go from 45 to 50, completely skipping over 48. So that is not a factor of 48. Make sense? Okay, 1 and 48 are a factor pair. 2 and 24 are a factor pair. 3 and 16 are a factor pair of 48. 4 and 12 are a factor pair of 48. 5 is not a factor of 48. 6 and 8 are a factor pair of 48. So in order to write that as it asks us here, the following arrays are just the multiplication equations that can be made. And we can see those right here in this box, circle that I made. 1 times 48. 2 times 24. 3 times 16, 4 times 12, and 6 times 8. So all I've done here is taken these multiplication equations and written them out lengthwise as it's asked us to do here. Now last part it asks in the problem is to draw and label one of the arrays. So I could make a picture here of one row and 48. I could do 2 rows, so 2 rows, and 24 in this row and 24 in that row. But that would take a lot of space, and that's probably not going to be a nice arrangement on the tray that we've got. I could do three rows, and 16 in this row, 16 in this row, and 16 in this row. I could do 4 rows and have 12 in each, but I think I'm going to go with this one because it's going to be the closest to a square, because they're the closest numbers. 1, 2, 3, 4, 5, 6. And if this was art class, I'd spend time drawing with cute little strawberries everywhere, but remember you have to draw 48 cute little wet strawberries, and that's going to take a really long time. And rather than sitting here watching me draw 48 little strawberries, now I've got my 6 rows with 8 in each row. So 1, 2, 3, 4, 5, 6 rows. 1, 2, 3, 4, 5, 6, 7, 8 in each row. So that'll be the label of one of the arrays. I would just label it 6 and 8, which are the factor pair, the last factor pair. I could have chosen any of these factor pairs to show. So that is the factors. Now what it's going to ask is if a number is a multiple of 4. So in this case, determine whether 64 is a multiple of 4. And there's 2 ways to do that, as I had said previously. You can divide, if you're comfortable with your division, or you can count your multiples of 4 to get there. Okay? So we can do the division for, if I have 1 10 there, that's going to get me 40. And 6 minus 4 is 2, which leaves me 24 when I do my subtraction. 4 times what is 24? 4, 8, 12, 16, 20, 24, 6. So we've got 10 plus 6, not 106. I'm using their boxes to do that pattern that we've discovered we like better. 24 minus 24 is 0, so there's no remainder. There is no remainder, so 4 divides 64 evenly, so 64 is a multiple of 4. If we had a number besides 0 here, it would not be. But go back, 10 plus 6 is 16. That is our, it would be 16 times 4 would be my factor pair. Now I can do the same thing. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. So all these first multiples I can get just by doing my fours song, as we practiced a bunch of times. And then to go on from 48 to see if we count 64, I'm just going to keep adding another set of 4. So 48 plus 4 more, 48, 49, 50, 51, 52. So 52 is going to be the next multiple. And then I'm going to add another 4, which is going to get me 56. And 56 plus 4 more is going to get me 60. You can pause it and do the math yourself. And 60 plus 4 more will, in fact, get me 64. So I know, because I said 64, I know that 4 is a multiple. And if I needed to get my pair, I know that 4 is going to be one of them. The multiple will be 64. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 times 4 is 64, which is exactly what we saw over here. So those are the two ways. If you don't feel comfortable dividing, you can do the multiples this way. If you end up higher than 12, which is what our songs usually go to, you just keep adding that multiple. See if you get to the number that you're looking for. Okay, so for the practice here, 46, you're going to get 1 and 46. It'll always be 1 in that number because that's the identity property. Just like this one, the first one will be 1 and 76. Makes sense? And because this is even, I can tell that 2 is going to be another one. So 2 times what will get you to 46? And again, this is even, so 2 is going to be here as well. What is the third one going to be? Times what will get me to 76? That's what you're going to do for the factor pairs. Here, you're going to find is 66 a multiple of 6? So you're going to choose which option. Do you want to show your division, or do you want to write out the multiples? This one, it would be easier to write out the multiples because when we do our song, we're going to say this one. This one is pretty high, and this one is pretty high too, so you're going to be writing a lot of 3s if you choose to do your multiples, which you can do. It's just going to take you more time. You can also divide 4 and 86, which is the way I would try because I feel more comfortable with my division facts. If you're not feeling confident with your division, do it the long way. It will still get you the right answer. There's nothing wrong with taking more time. Now on the back of this page, it has the factor pairs, which we did on some guided practice. And instead of giving you all the space, here you're just writing the factor pairs out like we saw on the example. So you can refer back to the first example if you're not sure how to show it here. It's the same thing, just not written out with all the ands. You would just write the ordered pair with a multiplication sign for 12, 13, and 14. Now, 15 through 18 is just, you're either going to write your multiples or you're going to divide to see if this number is a multiple of this number. Now, this one is a little bit different than what we've seen. So they've given you a bunch of numbers, and you have to see, oh, is this a multiple? Is this a multiple of this? So in this case, I'm going to count by 3s. 3, 6, 9, 12, 15. No, I don't say 14. So 14 is not going to be a multiple of 3. 3, 6, 9, 12, 15, 18. 18 is a multiple of 3. Make sense? So all you have to do is circle the numbers that are multiples of the given number. So it's basically combining and giving you several problems all at once and going through to check each one of these, either counting up or dividing. You're going to do the same thing for 7 and for 9. On your word problems, it tells you list all the factor pairs of 49. So this is just like our strawberry problem. You're going to find all the pairs, factor pairs for 49 and list them out. This one is asking basically, is 73 a multiple of 6? So you'll need to count by 6 or divide, depending on which you feel comfortable with. This one, you've got several options, any number 51 to 59. Choose 2 that have a factor, that both have multiples of the same, that are both multiples of the same. And choose something other than 1. We know that 1 is a factor of all numbers, so choose something else there. Number 25, without dividing or listing multiples, how can you tell if 61 is a multiple of 6? Think about that, and please complete that problem. Thank you.